At this point, we have seen many different ways to solve linear equations, so we are just going to practice it more today. You also saw cases where you could get no solution. Well, I'm going to show you cases today as well where you could get an infinite number of solutions, meaning no matter what number you plugged in for the variable, it would work. So let's just start with number 1 here. The very first thing I'm going to do is I'm going to combine like terms. So my like terms are 3y and 18y. 3y plus 18y is 21y. And then I'm just going to rewrite the minus 9 on that side of the equal sign. On the right hand side of the equal sign, I have 12 and 24 are like terms. 12 plus 24 is 36. And then I'm just going to rewrite the plus 6y. Just like I have seen with previous problems, I need to get my variables on one side, or my pieces with the y's on one side and my numbers on the other. I choose to try to keep things positive if possible, so to do that I'm going to add the 9. I'll be left with 21y equals 36 plus 9 is 45 plus 6y. Now since I moved the numbers to the right hand side, I'm going to move the 6y to the left hand side. So I'm going to subtract 6y. 21y minus 6y is 15y equals 45. To solve for y, I divide by 15. I know I'm running out of room here. I apologize. And I'll write it off to the side. 45 divided by 15 equals 3. So y equals 3. You could always check by plugging in to your original problem and making sure that left hand side equals the right hand side. Number 2, I'll start by combining like terms. On the left hand side I have 12x plus x, which is 13x, minus 3 equals, and on the right hand side I have 5x plus 8x. 5x plus 8x is 13x, minus 3. To solve this one, again, I get my variables on one side, my numbers on the other. I'm going to choose to subtract the 13x. So I end up getting 13x minus 13x is 0. I can just cross it off. I am left with negative 3 on the left hand side and negative 3 on the right hand side. Now we saw with no solutions you ended up getting something like this, except they were different numbers. You have to ask yourself, is it true that negative 3 equals negative 3? The answer is yes. Negative 3 always equals negative 3. When this is the case, you have to tell me you have an infinite number of solutions. So infinite solutions. And that would be it. No matter what number you plugged in for x in number 2, it would work. Number 3. To solve number 3, the very first thing I'm going to do is distribute. So I'm going to distribute the negative 8 into parentheses. Negative 8 times 3 is negative 24. Negative 8 times negative 1 is a positive 8. Negative times a negative equals a positive. And I'm rewriting the rest. I'm going to want to try to keep things positive if possible, so maybe I'll add the 24n. On the left hand side I end up having an 8. 15 plus 24 is 39n plus 125. Because I moved the n value to the right hand side, I'm going to move the number to the left hand side, so I'm going to subtract 125. 8 minus 125 equals a negative 117. Finally, to solve for n, I can divide by 39. Again, I'm going to write it off to the side. I get n equals, and negative 117 divided by 39. You can divide it in your calculator. You might not think it works, but it does. It's a nice number. It equals negative 3. The reason it's negative is because you have a negative divided by a positive. Number 4, I'm going to start the same way as I did with number 3. I'm going to distribute the 2. So I'll get negative 10m plus 2. A negative times a negative is a positive. Equals negative 10m plus 2. Maybe to try to solve for this one, I'm going to choose to add the 10m to the left-hand side. Negative 10m plus 10m is 0, so I can cross it off. I end up getting 2 equals, and on the right-hand side I'm left with a 2. I see again in this case, I end up having something that's always true. 2 equals 2. When that happens, we don't say it's a no solution, we say it's an infinite solution. Infinite solutions. Meaning any number I plug in will work. Again, you have numbers 5 and 6 to try down here. Please try them, and we'll check them in class tomorrow.